we're going to learn about U substitution with everything else. So we're going to learn about the uses and the applications of U sub in different mathematical concepts. So first we learned that U sub is the reverse chain rule. So before we've learned that chain rule is helping us find the derivative of a function within another function or different multiple functions. So then we find the derivative of each separate functions and then multiply them out together. And now with the integral of the derivative functions, we can find the original functions plus c, because we need to recognize if there is some sort of constant or if there is not a constant. Let's take a look at a first example with using U sub in integrals. So the first problem says find the integral of sine squared x cosine x. So when using U sub, it's always helpful to find some sort of pattern, and we also need to know that U sub deals with using derivative functions. So if we see here sine and cosine, well, we can say that the derivative of sine is cosine. So we can set u equal to sine x. If we find the derivative of sine x, then we get cosine x. And then we can substitute sine x with u times cosine x times du over cosine x when we switch dx by dividing cosine from both sides and multiplying them with the integral. And then after that we can multiply cosine out, and that'll leave us with the integral of u squared du. And then after that we find the antiderivative of u, which is u cubed over 3 plus c. And then after finding the antiderivative, we replace u with what was original, with the original function, which is sine x. So the final answer for this problem would be sine cubed x divided by 3 plus c. Let's take a look at another example, and this is what I call back substitution. So the problem asks find the integral of x plus 3 times x minus 1 to the power of 5. So there really isn't much of a pattern here, but we can say that we can set one of these polynomials to u. Let's use x minus 1 as u. So u equals x minus 1, and then we take the derivative, which is du equals dx, because the derivative of x is only 1. So that multiplies to 1 times dx. After that, you substitute x minus 1 with u, and then we need to change this x somehow into u so that it can find the antiderivative or the integral. So then, looking back here with using the u sub, we can change this x into x equals u plus 1, which is the part of back substitution, going back into the original function and changing it into some sort of useful variable that we can find the antiderivative. So substitute x with x plus x over here, change it to u plus 1 plus 3 times u5 du. And then combine all like terms, change it into the integral of u plus 4 times u to the power of 5. And then distribute the u. And then now we have all the variables that we can be able to antidifferentiate. Then we can find the antiderivative of the function, which changes to u to the power of 7 divided by 7 plus 4 times u to the power of 6 over 6 plus c, always putting the c in at the end. And then after that, we go back to see what our u substitution was, which is x minus 1. And then our final answer would be x minus 1 to the power of 7 to over 7 plus, and then we simplified it into its simplest form, 2 times x minus 1 to the power of 6 over 3 plus c. So that is the back substitution, what I call method for this specific problem. Now, u substitution doesn't have to only deal with integrals, but they can also apply with different mathematical concepts, such as polynomials and finding the zeros. So for this problem, it's asking find the zeros using u substitution. So the problem is x to the power of 6 minus 9x cubed minus 8 plus 8 equals 0. Well, let's take a look if we just directly found the zeros. You can factor out x cubed minus 8 times x cubed minus 1 equals 0, and then you set x cubed equal to 1 and 8, and then find the cubed root of these two values, and you would get x equals to 1 and 2. Well, this method helps you find it by directly finding the zeros. Now let's try using u substitution here. Now we said u substitution can be used by finding some patterns in the original function. Well, if you take a look at x to the power of 6 and x cubed, you can set u to x cubed to factor out into x cubed squared minus 9x cubed plus 8 equals 0. Substitute that to u, and that'll change into u squared minus 9u plus 8 equals 0. And then factor that from there, that would be u minus 1 times u minus 8 equals 0. And then find u, which is 1 and 8. And then after that, you can replace it from x cubed. And if you see here, this is the same as this over here, and then you can cubed root the two values, and you would get x equals 1 and 2. So that is some different sort of application with using u sub, not just only integrals, but it can also be used in basic math.